Hi everyone, and welcome to episode 3 of Imagine Cup Junior as part of our DreamSpace HomeSpace series. My name is Amanda. Joining me today is Corey.
Hi everyone.
And as usual, we have lots of our team here working on the episode today. So if you have any questions, as always, you can pop them into the Q&A bar. And we are going to be covering quite a lot of detail today, as we are in a lot of these Imagine Cup episodes, to give you that kind of base knowledge that you're going to need, hopefully, to develop out a project to enter into the Imagine Cup Junior. So at points today, you might want to take notes, you might want to look something up, because some of the terminologies might be a little bit new for you. So it might be worthwhile kind of pause and mulling them over before you play, and we continue on. All right. So up to this point, we've done 2 other episodes. The first one, we looked at the fundamentals of artificial intelligence. So we looked at that whole formula, remember, where we said it's going to be your data plus your algorithms and machine learning. And then we've kind of between that episode and the next, we've really delved into the data sets idea. And last week, we then introduced the machine learning kind of content, so to speak, the very beginning of it anyway. And so we're going to kind of pick up where we left off last week in terms of machine learning and look at the categories that we finished on last week, but then also delve into some new ideas. So the new things we're going to introduce today are deep learning, and the idea of deep learning that occurs with something called neural networks. So as you can see, there's some brand new terms maybe for you right there, and that's what I mean about maybe needing to pause and think things over at any point. We also will put up these support documents after the webinar, as always, in our waitlist collection, which we'll share the link with at the end, so that if you need to do some further reading and there's other kind of useful links and demos you can try out, because I think the more hands-on you get with this stuff and think it through, the better it is. And again, today we'll do a couple of demos with you as well, won't we, Corey? You've got a few demos actually.
Yeah, a few fun ones as well.
Yeah, exactly. And again, at home, when we're doing those, guys, pause and go and try those demos out as well. Okay, so last week we left off with the idea of 2 kind of categories of machine learning that we were talking about. So you can see there it says ML, which is just machine learning. And the 2 categories we looked at were supervised machine learning and unsupervised machine learning. So I just want to recap over what they were, and then we'll move on to another area of machine learning that we want to talk about today. So supervised machine learning, remember, we talked about this last week. It was when we had a lot of labeled data, and we talked about data labeling last week as well, what that was when we put bounding boxes, for example, maybe around an image, and we tagged it with words that were relevant or linked to that image. So the data was labeled, and we get loads of labeled data, and we use that to train the program and train the algorithm, because we know what the outcome is going to be. So with this type of machine learning, remember, we know what the end goal is, we know what the end result is. So that trained data is using, or that labeled data is training the algorithm to get to that end goal with the supervised methods. Okay, and we did talk about last week the idea that can be a bit tedious, and Corey's going to touch on this later again. So there's a lot of maybe finance involved, a lot of time involved in doing this, but it will lead to a very accurate program by the end, because you've trained it to that point. We also talked about unsupervised machine learning. So remember, that was when there's the data set is given into the program, but there's very few labeled data points. So it has to cope with these few labeled data points and use them to coach the other data and get it to as accurate a level as it can get to. Okay, so what normally happens in unsupervised machine learning that we talked about last week is they use clustering as a method, where they look and they identify traits and patterns that they can observe, and they cluster them together in groups, and that's used then to inform the program. And the example we gave last week, Corey, was marketing, wasn't it?
Yeah.
So we looked at the idea that Corey, for example, might exhibit certain behaviors when she's doing online shopping. So she might always go towards certain things. Corey, what would be your most common online shopping, say, search word or product?
Probably just like basic t-shirts or something.
Yeah, so what's happening is the program is going to identify behaviors about Corey and her as a shopper, and it's going to cluster her with a group, maybe with people who are doing similar things, and then it knows how to target their marketing towards Corey, for example, because they know these are the behaviors that she's exhibited, and she's in this group, she has these traits. So that's kind of what we looked at there. So they were the two categories. Now today we are going to kind of move down from that subset of machine learning that you see there into deep learning. So just to kind of make sure we're very clear here, remember, artificial intelligence is ultimately what we're talking about here. The idea is for you at home to have such a good understanding of this stuff that you'll be able to come up with your own idea to enter a project. You don't, remember, have to program and build out this product, but we want you to really understand the intricacies and what is involved in how this works. So you might decide that for your AI for Good project entry, that you really want it to be a really efficient AI system and really human-like. And in that case, deep learning is going to be as close as you're going to get. So we're looking at a subset of machine learning here, which is going to be looking at something called neural networks. So getting the machine, the computer, to really function the way our brains as humans function. And this is really, really complicated, right? I don't know, Corey, did you do biology?
I did do biology in school, but it was a long time ago, so you might have to refresh my memory.
Okay, so I get a little bit excited here because I'm a biology teacher. So anything back with biology, I get pretty excited about. So the brain, obviously, it's funny, people would often say that they wish that they had a brain like a computer. Well, actually, a computer, it's kind of hard to get a computer to have a brain like us. Okay, our brain is so intricate and works so efficiently and is able to think in so many different ways because of its neural network. And what programmers are trying to do with deep learning is get that neural network to mimic and behave exactly like our brain. And that is so difficult, because I'm going to quickly jump into some biology. I'm going to indulge myself a little bit here because I love biology, and just talk about, and just hopefully the understanding of how our brains work will help you understand what we're trying to get a computer to do. So inside our brain, guys, we have lots of neurons, and they're kind of nerve cells. So if you've done biology, you might be familiar with this idea. And nerve cells are all over our bodies. They're not just in our brains, but we're just going to focus on the brain for a second because that's what we're trying to get the computer to mimic, okay? So inside these neurons, if you can see here on my slides, I'm going to use my cursor here just to point out a few things. So this here, for example, this is one neuron. And basically messages are received into the neuron here. So the nerve cell receives a message, okay? So for example, when we think about a neuron, say our nerve cells in your hands, okay? If you touch something hot, okay, those nerve cells in your hands pick up that message and they receive it. And that one cell will send that message along here, and it will then pass the message to the next neuron that it's connected to. But what's really interesting is in a neuron, we have all of these junctions and gaps, and there's loads of little branches. Can you see that, Corey, the way it's looks like little branched off areas there?
Yeah.
So they're called dendrites, and they pick up the message. So when the message passes from one neuron to another, there's actually lots of receiving, so to speak. Let's think of them as hands. So lots of hands that can receive this message, okay, like these little branches here. Okay, when we look at this in depth in this part of the image, what's happening is the message gets to the end of this neuron, and then it passes across the gap into this area here, into the next neuron. Okay, so it might attach here, it might attach here, it might attach here. There's lots of areas it can attach to. And if the message is strong enough, it will actually fire that neuron to send the message on again. So it's like a domino effect. Corey, do you ever see that video of dominoes all lined up and you click one and they all fall?
Yeah.
Yeah. So we get to it. If the domino falls a certain amount to hit the next one, it's going to knock as well. So it's like a threshold is what they call it. And when I'm saying all this, you can see how complex this is for us to even think about with our brains. So this is what we're trying to mimic in a computer, which is really advanced, because you can see here my statistic about the human brain, that it has 86 billion neurons or nerve cells. And the thing about that is, not only does it have 86 billion neurons, but each of them might be also connected to thousands of others because of all these little junctions and gaps that we have. And so what we're doing here is we have all these, with these junctions, we've all these networks. We like a big mesh of a network, a big matrix where all of these neurons are interconnected. It can send messages across back and forth to each other. And the really interesting thing is as they send messages and as they keep firing, so to speak, they will actually remember things and they'll learn things as they go. And that's what we're trying to get the computer to remember with machine learning. We want it to learn things, we want it to remember things so that it's able to get better and that the AI program works really efficiently. So Corey, that's pretty complex, isn't it? If you think about our human brain even.
Yeah, definitely.
So that's the brain, and we're trying to mimic this now in what we call an artificial neural network, because it's not real, okay? It's like AI, it's not a human thing. That was the human side that I showed you there. We're now trying to artificially replicate that inside a program, a computer program or a machine. Okay, so we're simulating it. We want that, basically this idea of these junctions and these connections that our neurons can have to be mimicked inside a computer, and looking at something like this, so that it can recognize patterns, it can learn things. And remember what I said about deep learning, it's really human-like. It becomes very human-like as we go. And you'll see that today with the different demos that we do, how human-like it becomes. Okay, so if you have any questions, remember, just throw them in the Q&A, guys, because I'm going to pause for a sec if you need to, because I know that's a lot of information. So let's now look at how we set up an artificial neural network. How do we try and replicate or simulate what our brains are doing inside a computer program? Okay, so some of these words look familiar, Corey, don't they?
Yeah, inputs and outputs, I think we've looked at before, haven't we?
We have, yeah. And if anyone here has done any computer programming, or you've joined us even for our Python webinars on Tuesday where we program, inputs and outputs are really common. You often hear programmers talk about inputs, so getting information in, processing the input, and then giving something out at the end. Now, with artificial neural networks, we don't just have one input, one process, and one output, because you can see all these lines. It nearly looks like a web. Do you notice that, Corey?
Yeah,
and
they're all like intercrossing and stuff.
Exactly, and that's exactly it. If you notice it, if you look at this one input, for example, this one input will actually be linked with all these other layers. So these are called the hidden layers. And there could be multiple hidden layers. In this instance, we have two. Okay, so this one input here is actually linked with every part of the first hidden layer, and so is this one, and so is this one, and so is this one. So you can see how intricate it is in terms of being able to link in. And when it links with this hidden layer, then these might actually be weighted enough or reach that threshold we kind of talked about with the brain to pass on to this layer, and eventually we'll have an output at the end. Okay, so the input units, remember, they're taking information from the outside, which is exactly what we talk about from a computer programming perspective as well. The hidden layers then are kind of like the way our brain is working, with all those connections we talked about with the neurons, okay? So they're able to connect and fire across messages to each other. And eventually, once it gets through those hidden layers, it should reach our output units at the end, which will accomplish the task. Now, the thing is, when we think about AI broadly speaking, but not deep learning, it might achieve a task, but if we slightly change an input, it might not be any different on the output end. But with something like this, because of how intricate it is, even if we slightly change an input, because it's able to link in with so many different hidden layers here, and so there's such a big network, it means that even the slightest change in input should result in the slightest change in output, which, I don't know, Corey, if you agree, is very human.
Definitely.
So even if we slightly maybe change the way we ask a question, someone else might slightly change how they answer the question because of that slight little difference. Sometimes when we look at AI, it doesn't use this deep learning, so it wouldn't be that accurate, but this will be because of its neural network setup. Okay? So you think we're getting really in depth here now. So we're nearly onto a demo, you'll be glad to know, so just stay with us. So there's three types of neural network types or typologies that we want to touch on here. Okay, that kind of it's so when the engineers are setting up their neural network, they can kind of pick between few different types, and these would be the most popular ones. The first one is called a feed-forward neural network, which if we think about it, makes complete sense. Think back to that diagram I just showed you. So I'll just actually go back so you can see. So with the feed-forward neural network, it's literally that the message comes into the input layer, goes into the hidden layer, and goes to the output layer. So it's feeding it forwards from input to hidden to output. Okay, so it's quite a straightforward neural network, and it's the most basic type. Okay, and remember what we showed you there is that each layer is connected to the layer previous to it in every way, and that's where all those branches come out. Okay, so that's the most basic one. If we want to step it up a level, we have something called a recurrent neural network. And that one's a really interesting one because we kind of bring in the idea of memory here, in that when it sends an output or when it sends the message on, it remembers it and it feeds it back. So at the end, when the output occurs, what happens is the message, it will remember what it just outputted, and it will then feed back through the hidden layer and then back eventually to the input layer what it outputted. And so that should actually help change the weighting on things and how efficient and accurate the computer is. So this really helps with the learning side of the deep learning network. And so it's used a lot in things like languages, and we're going to touch on languages today, Corey, aren't we?
Yeah, definitely. Later on, we're going to go through them.
Yeah, in recognizing language and being able to translate. I'm going to do it, and Corey's going to touch on that as well. And lastly, we have the most complex one that we're going to discuss here anyway, which is a convolutional neural, even the word is complex, convolutional neural network. So this is really effective though, and obviously like anything, the more complex things get, generally the more effective they might become. And what we have here is the layers that we looked at earlier in the image. They're actually organized out into width, height and depth. And not all, because there's so many of them a lot of the time, not all neurons are actually connected to each other like we looked at in previous layers. But what they do is they get the final output, they get it reduced down to a vector or a single score, like a probability score, or a dimension. So it's really narrowing it down to a very, very specific thing. And Corey, you're going to show us facial recognition and look at the kind of Azure side of vision, our cognitive service of vision. So you're going to see that in that, aren't we? We're going to see that idea of getting it down to a score point.
Yes.
Yeah. So that's the deep learning as well, guys. So there's three kind of neural networks. So why are we talking about all this? Remember, this is all to do with shaping your knowledge of your project. So when you start trashing out your ideas, and over the next, after today, the next few episodes, we'll hopefully help with that, how you can get down to a problem statement. And when you start kind of delving into it, you might decide that you want to use deep learning in your program. You think this would be a good idea. You might decide that with the deep learning you want to use, you want it to save its output and improve. So you might decide it's recurrent. So it's just to inform your knowledge, because obviously if you have that kind of information in your project submission, you're going to, hopefully do really, really well. Okay. Okay. So we're going to look at a neural network in action here, an example. So I'm going to show you a video here of a product called Microsoft Translator. So obviously, exactly what it says, it's translating languages. And you're going to see in this video how this has been used to help parents in parent-teacher meetings, basically. But this isn't AI for good, so to speak, but it kind of is. It's not an AI for good category, but it's just showing you again how these tools can help people. All right. So we're going to hop in straight into Translator. Well, it is actually, I'm just thinking here, it is an AI for good. It's AI for accessibility also. But in this instance, it's going to be just to help parents in a school setting. Okay. So we'll watch the video and we'll talk about what actually is happening in this afterwards.
Today's classrooms reflect the increasingly mobile society we live in. The student population is becoming more diverse, and non-native speakers constitute a greater portion of classrooms than in previous generations, or even just a few years ago. Parent-teacher conferences are a key instrument for engaging parents with their children's teachers and the school community. But what if parents aren't fluent in the language of their child's school? How can they gain an accurate picture of their child's progress? How can they target areas for improvement when there is a communication gap with the instructor? Today, Microsoft offers a groundbreaking new tool that bridges the gap between parents and the teachers responsible for their child's education. Microsoft Translator provides real-time translation in a free, easy-to-use tool that works on any device with web capability.
Welcome. Thank you so much again for coming today.
Muchas gracias por enseñarle a mi hijo.
Your son is very kind. He's doing really well in my class.
Eso me da mucha alegría.
Do you have any other questions for me?
Going beyond the classroom, there are situations in education where parents can benefit from real-time translation into their native language. When parents are able to efficiently touch base with school staff, navigating school practices and policies becomes effortless. There are many interactions between families and schools that are simplified with Translator. The setup for Microsoft Translator is so quick and easy. Just visit aka.ms/translator.edu to learn more.
Okay. So what you're seeing there is real-time speech translation. And what you see there was a parent coming in to talk to the teacher, and traditionally, maybe before this existed, there was a language barrier there. So maybe the parents' first language wasn't English and the teacher was relaying this information about their child in English. So we're breaking down that barrier with translators. So that's why it does kind of fall into AI for accessibility. But what we want to look at is how is this related to what we've just talked about, which is deep learning and neural networks, and what's actually happening here, okay? So this is part of one of our cognitive services, and it's been built, and again, Corey's going to go into some of these afterwards. It's been built in such a way that it's based on that deep learning model with the neural networks. And what it's able to do is it's able to take in the context of what someone is saying or listen to it, put it into the correct context, and then relay it out in another language. So there's actually, in that quick time, very quickly it happens on someone's phone that the information might pop up. But even in that space of time, there's a lot happening in the background, okay? So we want to look at what is happening in the background, right? So bear with me on this, right? If we think back to what you just watched in the video, say, this is the teacher's speech, and the end goal is to get the parent's speech in the language that they want to hear it, in the language that's accessible for them, okay? So the teacher speaks, and what happens is they obviously speak in English. This goes into the first AI powered area where it's speech recognition, and it will transcribe it. So here's what the teacher says in English, and it writes out. Now, in this instance, what it's written down is, can you hear me? Now, couple of things. When we speak, and I've probably done it numerous times here already in today's webinar, and Corey, we always say this, don't we? We say and okay, and we fill time. That's natural as humans. We fill time sometimes when we're speaking, and sometimes we repeat words. So I might say sometimes, because I'm trying to think, what am I saying? So in this instance, someone said can twice, which probably is not relevant. And the machine is actually going to know that. We'll talk about that in a second. And the other thing to notice here is, can you hear me? Here is not actually in the correct format. So what happens is this text that's been transcribed then gets fed into an AI-powered program called True Text. Okay, it's a natural language processing one. We talked about natural language processing last week. And it's able to recognize that second can shouldn't be there. That they didn't mean that. That was just a natural human thing to do, but actually they just mean can. And then here is wrong. So look what happens here. It actually puts it into the correct format. All right. So that's amazing. And that's because it really understands, with the neural networks, it's able to get a really good understanding of the context of the conversation and the sentence. And it understands human behavior. It understands that we might just say a word twice. Okay. When that's translated into the correct format here, okay, or transcribed, it then gets passed into the machine translation tools that's going to change the language. So this, can you hear me, is in English, goes in and gets translated in this instance of the image into Japanese, okay? And then when that Japanese comes out, it's used text to speech will then translate that from written into something that we can hear in audio. And that's basically what the parent was hearing at the other end. Okay, so that's pretty cool, isn't it, Corey?
That's amazing.
It's really amazing, but it just shows you again, guys, the intricacy and the depth that has to happen behind these tools. We use them without really thinking twice. I know I do anyway, but actually the amount of engineering and the amount of time that will be taken to build this out is massive. Okay. So a couple of examples we're going to jump into, and then Corey's going to do loads of demos with you as well. So we have deep learning with celebs like me. Now, this doesn't exist anymore, actually, which I'm kind of raged about, because I personally would like to see what celeb I was matched to. I don't know about you, Corey.
Same.
So I'd like to see what it thinks. So what celebs like me used to do, it was a Microsoft thing, was when it existed, you could put your image in, and first of all, it would be able to, you know, recognize that your face is there, detect your face, and then it would align your face up. And then once that was done, it would pass it in that it could be analyzed with its neural network and its deep learning tools. And these deep learning tools were set up using and trained using Bing Image Graph and Bing Knowledge Graph. So these two things basically work together. So between all of this area here with our neural network, it was able to analyze our face and the landmarks in our face and match them to the closest looking celebrity. So now, in saying that, maybe it would give me someone I didn't really want to look like. So I don't know, sometimes that's not knowing these things. So that would have been, that's really cool. Another thing that we have, and I'm going to demo this for you now, and we might get you to pause and go in and try this out with us. Another really cool thing is something called AI lab, in our AI lab, is called vector search. So Corey, when you go on to a search engine and you type something in, like normally it uses the keywords, doesn't it?
Yeah.
A lot of the time. It's like keyword or entity recognition sometimes. So vector search was been set up by AI Lab, and what it's doing is it's actually not just checking the word you've entered, or sometimes you can enter a picture. So you might take a picture of something and it will be able to analyze the picture, but it's not just checking that, it's actually checking the closest nearest matches too. So it's really using that web. If you think about that web image again, with all the different links, it's searching through all of them. So what it will mean is the search is really, really accurate at the end. So I'm just going to hop in and quickly demo this for you, and you guys can try it out as well if needs be. Oh, sorry now.
I'm excited to see how this works.
There we go. Sorry, had to move my screen there. Okay, so this is vector search. So you can see here it says uses AI to understand and analyze your search query, giving you faster and more accurate results. Now, this one is it's a deep learning model. And again, we're using images here as an example, okay? Now, Corey, knowing you, I think the first thing you're going to click on is the dog.
Yes, you're right.
Which dog would you like me to click on? I'll let you click.
The middle one.
The middle one?
Yeah.
Okay, so basically, say for example, guys, we took a picture of this dog, and it's not going to just look for this type. What you'll see now in the output is, so I'm going to confirm selection, and it's searching. Okay, so it's looking for all, it's finding the nearest matches, and it might go through a range. It might not be the exact same looking dog either. It might be slightly different color coat, blah, 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 because it's able to actually use this neural network to really search across a huge range. And therefore the results that come back tend to be more accurate, but also give you a lot more options as well. Okay, a lot more accurate options. So there's a lot of information. You can see lots of information about vector search online. So if you guys want, I'll pop in the link in the Q&A now in a second, because Corey's going to actually take back over now. And I can pop that in. And if you want later on, you can go in and read about it. There's actually a really good video where the engineers explain why they built it and how they've built it. So it'll give you a little bit more understanding with this, okay? So just to recap, before I pass you on to Corey, guys, I just want to recap over what we've covered there now. So what we're trying to delve into, remember at this point, is deep learning. Okay, so we know what AI is. We know we're trying to get a computer to mimic human intelligence. We know that a subset of that is machine learning. So again, getting the AI to actually learn and improve and improve the task and improve for the person's experience. And remember, deep learning is a subset of that. So thinking about your projects, you can be thinking about where is your project maybe going to fit in, and hopefully this has helped add to your knowledge. But Corey, I think it'd be cool now for you to do some more demos of some of our deep learning cognitive services maybe.
Okay, sounds good. So now we're going to actually have a look at some apps that use AI, okay? But before we do that, we need to actually understand what an API is, okay? And all an API is, well, it stands for Application Programming Interface, okay? And it's basically how software components interact with each other, okay? It's a set of commands that's used in programming to create apps that are able to interact with external systems, okay? And APIs are one of the main ways of interfacing with cloud services. Now, we did discuss cloud services last week, and we talked about how cloud services it's just a system, okay? It's a system with a lot of servers, and those servers are then hosted on the internet. Now, we actually took an example of a video streaming service who host all of their data on the internet instead of like on a local device or a computer. But let's explore some of the major APIs, okay? And one of my absolute favorites is facial recognition. I just think this is the most fascinating API, okay? So facial recognition is actually built to recognize one or even many faces based on machine learning predictions of facial features. And these facial features could be facial hair, the color of your hair, your age, your gender, just to name a few, okay? And how exactly the machine does this is it maps out your face, okay, using landmark points, okay? So if you look here, the machine is mapping out this face, and there's actually over, I think it's 27 landmark points on any given human face. And what the API does, it actually targets these landmark points and identifies, searches, and matches your face to the closest one that it has in its repository. Okay, so this face recognition service that we're going to use now on Cognitive Services with Microsoft has like up to 1 million faces in its repository. Okay, so what the API does, it takes those mapping points and searches and matches them to what it has in its data. Okay, now facial recognition can identify people, but it can also identify your emotions. So it can distinguish between different emotions that you have, which is crazy because it can tell whether you're angry or fearful or happy or even surprised. And it can actually recognize, it's smart enough to recognize and understand human expressions across different cultures. Okay, so let's actually just do a demo of it. What do you think?
Yeah, defo.
When I first learned about this, I think I done like 300 demos.
And I'll pop the link in here in the Q&A, Corey, actually, for people as well.
It's so fun to try. So if you want to watch me do it and then pause me and then try it yourself at home. But I think when I first done this, I used a picture of me doing every single pose, like happy, scared, just to see if it could pick it up. So I have this one here of me yesterday. And I am interested to see what I can read about me from this photo. Okay, so I am forever the poser. And if you look over here, okay, here is where, if you remember Amanda saying earlier on, you were talking about a score, weren't you?
Yeah, so working it towards with the convolutional neural network. And someone's actually asked a question about knowing more about that, so we'll put some further info in the Q&A about that. But yeah, absolutely getting it towards a probability.
Exactly. So here you can see that it's saying that my hair is brown, okay, and it's the most confident of that, because if you look at the score it's given here, it's saying it's 0.97, okay, and that is what we're trying to do, is we're trying to get it to a score closest to 1, okay, so 0.97 is the closest out of all those to 1, so it is confident that my hair is brown. And it is saying that I'm a female and I'm 22. Woo! I'm actually 27, so I'm very, very happy with myself. It's also saying that I don't have a mustache or beard or sideburns because it's giving me 0. It's picking up that I don't have glasses on in that picture and that I am wearing eye makeup and lip makeup. Now, interestingly, okay, I love the emotion part because you can see here that it's saying that it has no doubt in its mind in this picture, I am happy. And I think I do look rather happy in that photo. But what I think I might do now is, Amanda, I might take a photo of you.
Here.
But you through the facial recognition. Okay, I took this photo back in DreamSpace and we were testing out an app. Okay, so here we have Amanda. And it is
stones there, Corey.
I was very close. I think I just ambushed you. I was like, I need a photo. So it's saying that Amanda's hair is 100% brown, okay? So it's 100% confident, okay? Mine was 0.97, which is very, very, very confident, but it has no doubt in its mind that Amanda's hair is brown. And then if we go down, it is saying that Amanda's a female and she's 29, which is younger. So you delighted with yourself?
Yes. But I would like it to be a little bit younger, but yeah, anyway, I'll take it. I'll take any of it.
In fairness, mine was a selfie though, so that wasn't a fair comparison. So now interesting with Amanda's emotions, okay, it says that she is more neutral, okay? It is picking up a tiny bit of happiness, but it's saying that she's more neutral. And if you think about it, okay, that's because the landmark points that are at the side of Amanda's mouth are linear, okay? Her mouth isn't going up and it's not going down, so the landmark points are quite straight. So that's facial recognition, and if you want, you can pause me now and you can upload a photo and see what you get. But for now, we're going to pop back in and we're going to discuss some more APIs, okay? So some other ones that we've already looked at in the past couple of weeks is natural language processing, and Amanda just actually talked about that there. You were discussing that it picked up can you hear me, and then it knew naturally we talk like that, let's take out the repetitive word, let's fix the spellings. We looked at video indexer and image processing and sentiment analysis. Okay, so they're ones that we've actually already looked at during these webinars, but let's have a look in depth at some more. So speech authentication is actually a very, very powerful API, okay? It's a powerful verification tool. So if you think about it, everybody has unique voices, okay? We all talk different with different pitches and different tones, and every voice has its own personality, okay? But with speech authentication, what we can do is we can listen, or the machine can listen to these voices and actually find out the identity of the person behind the voice, okay? So again, I'm actually just going to pop in for a demo with this, and I'm just going to show you here. And again, Amanda will pop this into the Q&A. So
yeah, and for people actually, Corey, who might be watching on demand, this is all at azure.microsoft.com, and you'll see, you can go to cognitive services and find all of these demos that we're doing on there. Also, you can pause and look at Corey's web link, but just in case.
Yeah, perfect. That's a good show. And the one that I'm using now on the cognitive service is speaker identification. Okay, so here we have 6 US presidents, and what I can do is I can actually scroll down and I can pick an audio. Okay, and when I play the audio, the machine is actually going to recognize what president it is. So I'm going to just click audio 4.
And my first act as president is a prayer.
And there we go. It's after recognizing that it's George H.W. Bush. Okay, so that's really, really cool. So that's what it's saying, from his voice, it can recognize who's actually speaking, which is, I think, super cool. Okay. Now, with speech authentication, there is some other aspects to it, okay? And you've seen an example of this conversation transcript. So this is when the microphone or the API can actually capture speech or voices that's around the proximity of the microphone. And then it can convert it into multiple different languages. And you've seen that example there with Amanda when it was the parent-teacher conference, wasn't it?
Mm-hmm. Yeah.
So we've seen that API in real life, and we've seen the effect and how positive that can be for people. So that's conversation, okay? But then there's also your speech transcription, and this is just your speech to text, okay? So this is when we convert spoken audio into a text. So again, the API is able to recognize audio from the proximity of the microphone, and then it's sent to a server and then converted into text.
They use things like this, Corey, actually, in, like, if people are trying to think of examples, like, obviously we've seen the example in the video, but yeah, even if we go and look at things like the UN, when you've numerous different countries and representatives from all over the world, you'll often see that they have headsets on. Yes. And they're using a lot of translation and transcription tools to help them, you know, in the kind of course of the day, because it might not be their first language that they're hearing.
Exactly. So it really is super beneficial and helpful, isn't it? And, you know, for huge conferences like that, where people might not speak the same language, they have the APIs and the apps that use AI to actually help them understand what's being said. So it's super cool. Another API, right, is key phrase extraction. And we actually looked at this before. I think it might have been in webinar 1, where we typed in Microsoft Ireland is going to do amazing in the Imagine Cup Junior competition. And what the key phrase extraction done was it took out words like Microsoft and it took out words like Ireland. And then we were able to actually click into those, weren't we, Amanda, and find out more information about them.
Yeah.
Now, with key phrase extraction, it actually uses either supervised machine learning or unsupervised machine learning. And you've actually heard those terms so much now, you probably are saying them in your sleep. So we know it's supervised machine learning. It has a large amount of label data, doesn't it, Amanda?
Yeah,
so
and it has trains really efficiently, yeah.
Exactly. And then with unsupervised, it uses more of cluster algorithms. Okay. And, you know, supervised machine learning is probably the best one to use, but companies have to take into consideration it might not be cost effective. So you have to look at different ways around this. Okay. And then I think this is so cool. When I learned about this, I was like, wow, it makes so much sense. Okay, so named entity recognition is an API that, for example, you know, when we type into our search bar, we search for something and the web page will pop up. Okay, that is actually using named entity recognition because it's taken out keywords and it's categorizing them and it's giving you a more accurate search result. Okay, so if we look at this, for example, right, we have a large amount of text. And then in that text, they've actually categorized certain things. So locations and people and dates. Okay, so if we look at location, for example, it's after taking out all the key locations. So United States, it's after taking out Germany, New Jersey. And then if we look at the category date, it's also after categorizing the dates. Okay, and this is used when we are using the web, when we are searching for certain things. Named entity recognition helps us get a more accurate search results. Now, there's one more thing that I want to show you. It's sketch to code, and I think after facial recognition, I think this is the coolest thing. Yeah, I know I probably say that about everything, but this is actually really cool, okay? Because what this does, it actually, you can draw out what you want, let's say like a website to look like, and sketch to code will actually take that and convert it into HTML code. Okay, so what I'm going to do now is I'm actually going to show this. I'm going to show this as an example. So I'm going to pop.
Corey, maybe just explain for people who haven't heard of HTML what that is, like why that's useful.
So HTML is just a markup coding language, and HTML is actually used on every single website that you'll ever interact with. Okay, so it's a type of coding. So if you think about it, if you're still learning to code and you're not comfortable with doing your syntax yet, this website actually, you just draw out what you want that website to look like, and it can convert it into HTML for you. So you don't actually have to type out the syntax.
Yeah. So to understand handwriting like that, that's where the kind of, I think, the neural network and the deep learning comes in, because it really has to understand how to be mapping out how people write words and what they mean by different diagrams and stuff. So cool. I'm looking forward to seeing this.
Exactly. It takes a lot of work. So I think it might be in my downloads, sketch to code. Okay. So let's have a look here. So this is the registration website that we want. Okay, so we want a name, a username, a company, and to select a bullet point and upload a photo. And if you can see here, it is pretty accurate on what it's done. It's named event registration. It's given us a text box for name, and then it's given us an input for name. Okay, so this is where someone would input their name. Okay, and there we're coming across terms again like inputs and outputs. Then we have a username. It's misspelled a bit, but I think we can forgive it. And then it's given us an input again. Okay, and here we have select company area, finance, sales, and operations, and finally click here to upload a photo. That is amazing. If you think about the amount of work the machine is doing to actually understand all of that text, understand what's text, and understand what's an input, it actually is
so quick as well. Like you just click, and it was, so people can try that at home. Again, I'll throw the link in, and for those that didn't, it's on the slide as well that Corey went from, because that's a cool one to try out. You can, it doesn't have to be digital link. I think your one there, Corey, was digital link. Like you could actually take a photo of a piece of paper.
Oh yeah.
And it'll do the same thing, and just see out of interest how quick it is and how accurate it is. That's really cool.
So well done everyone on what we've covered today. We've actually went through a lot with neural networking and everything else that we talked through. So I think we'll do a learning recap. Okay, we'll go through, Amanda, I might quiz you on what we've done. Okay. So I hope you're ready.
One.
Okay, so
I forgot like this part. And if people want to try at home, actually they can pause and think about it, and then just to see check yourself kind of where you're at.
Yeah, definitely. If you can get into the Q&A there what you think the solution or the answer to this is, please go ahead. We'd love to see. So first one, a set of commands, protocols, and functions used in programming to create different software applications capable of interacting with an external system.
That was a lot of words, wasn't it? But
that was a lot.
The thing coming out of that is that it creates different applications. So I'm going to go with APIs.
Let's see if you're right. Woo! Well done.
Okay.
Good work. You were listening to me when I was talking about APIs.
Yeah.
Okay. The next one is a simulation of the interconnected brain cells inside a computer. This can get it to learn things, recognize patterns, and make decisions in a human-like way.
Oh, well, I obviously I love this because it's all to do with the brain, isn't it? It's trying to simulate the brain. So that was the fact that in our brain we have a neural network. So this would be the artificial neural network because the computer is doing it. Yeah.
Well done. Good work. Okay. A subset of machine learning based on neural networks that permit a machine to train itself to perform a task.
Okay. So the word there, the key word for me there is subset. So we looked at the big diagram earlier twice, I think, where we said machine learning is a subset of AI. and deep learning is a subset of machine learning. So deep learning, this one, Corey, I think.
Yep, good show. And that diagram really helps, doesn't it?
Yeah, absolutely.
When I seen that diagram, I was like, okay, that definitely makes it, you know,
Makes it a bit clearer.
Yeah, definitely. Okay, number 4, a system using a robust network of remote servers or computers hosted on the internet that store, manage, and analyze data.
I don't know where we'd be without it at the moment. So that would be cloud computing.
Yes, definitely. Well done. And I think this might be the last one. So one of 3 types of neural network. This saves the output of the layer, feeding it back to the input layer to help predict the layer's outcome.
So it's feeding back from the output to the input. That was one of our neural networks. And remember, it was the one that was really good at learning, and it was the recurrent neural network.
Well done. Good work.
Yeah.
Okay, so well done. You got all of them there.
As well.
Yeah. So we got through a lot today, okay? And in the next episode, we're actually going to start delving into your project, aren't we, Amanda? We're going to start looking at AI for good, okay? And your project using design thinking as well. So in the next episode, we're actually going to delve into design thinking, and we're going to be looking at your project. Yeah. So I'm just looking in the Q&A there, and just to remember that all the links are in the Q&A, but again, if you're watching this on demand, they're at Azure Cognitive Services. I'm not sure, is there any other questions there that are?
I think we've answered. I tried to kind of jump in every now and then. There's a few people wanting to know a bit more. So what I would say is, like, as in a little bit more in depth, and that's completely understandable. I'd be the same, and I am the same, and I'm learning something new. So yeah, exactly. Thanks, Corey. So we upload student guides, and actually, guys, we've actually covered 2 modules of the Imagine Cup today, believe it or not. So there'll actually be 2 files uploaded today. What they call module 3 and module 4. They're the 2 we've actually covered today. And in them, there's a lot more in-depth information. And there's also some really useful other links, like other demo links you can go and try, and other things to think about. But what's really important, guys, is to highlight that this is episode 3, and from episode 4 on now, we're going to look at AI for good, and we're going to really start trying to get you thinking, if you haven't already, about your project. Because remember, submission for that is June 12th. So we've just over a month to kind of, for you at home, whether you're doing this individually or a group. Remember, you can have someone was asking about the teams. You can have up to 6 in your team, or you could be doing it individually. And if you haven't started thinking about it yet, to think about it, because we really want you to enter this, because first of all, we've prizes obviously in Ireland, but we also, there's global prizes as well. So it's kind of cool. So we will, from next week on, start really focusing on that side of it. But up to now, if you need to watch back or read over the guides, up to now is just to give you that knowledge about AI, the subsets of it, the machine learning and the deep learning, so that when you're ideating and coming up with your ideas, you now should have hopefully enough knowledge to say, this is what I would get it to do. And I would use this type of neural network because, etc., etc.
Yeah, exactly.
Okay.
Having the background knowledge is going to be vital. So well done, everyone. And we'll see you next week at the same time.
Great. Thanks, guys.
Thanks for joining us. Bye.